Okay, I guess I'll introduce my as yet unnamed robot. So as anybody who remembers why I got some of the machine tools can probably attest to, one of the first things that I had mentioned was to start working on building a robot. Something that I want to do since I had been in college. Never really had the means to get started on it, and I don't know, none of the designs that I could make out of, common hardware store stuff ever really appealed to me. So here recently, now that I've got a CNC mill and a lathe down here and quite a few other assorted pieces of machine tools, I've gotten the opportunity to actually start working on it. So this is where I'm starting out. This is my initial creation here. For the moment, all it really is some crappy fiberboard up here connecting these two motor brackets together, and with a little junky caster in the back. The whole idea was just to kind of prototype this out and make sure that the drive system here would actually work. So I've got a little belt-driven drive system that's running, powered by two stepper motors, little NEMA 17s. Inside here, I don't know if those are real visible or not, but there's the motors. And then it's a pulley system to give myself a bit of reduction so that that motor could have a little bit better chance of turning these big 3 3/4 inch wheels, and still actually have a little bit of power left to them. So the whole idea behind this guy is going to be, the purpose at least anyway, was to build a sentry robot, so something that could patrol the house and monitor for the same kind of things that you'd set up an alarm system to monitor for. Movement of people, maybe some glass break sensors, stuff like that, so that it becomes kind of a roving patrolling alarm system. And a couple of my ideas are to add some of these guys, which are the passive infrared detectors. Those detect motion of bodies that have heat with them, so people, pets, what have you, if it's moving in its field of vision, it will pick up on that. One of the other sensors we'll be using is an ultrasonic sensor. The idea here being that if it keys in on anything that's interesting, that it can actually try to find exactly where it's at, and then I would have a camera mounted to it that would take some video of whatever it's looking at. And then these sensors would also be used all around the perimeter of the robot to detect for collision and detect for objects that are close by. And it needs some of the other common sensors you see on a bot, like bump switches and things like that, to detect actual impacts. So at the present time, it's really just a big prototype system. All I really wanted to find out was whether or not this drive system was going to work. It was a lot of effort put into making the parts for this. All of these were handmade here by me. The brackets were made on the CNC mill, and these pulleys were made on my manual lathe. So without further ado, I'll introduce some of the electronics on it. Alright, these are the electronics that are making up the prototype right now. This here is the Parallax Propeller Quick Start board. It's a 32-bit processor, 8 cores. So it can simultaneously process 8 different tasks. That's going to be kind of the brains of the operation. It's connected with a serial cable to this over here, which is the Diligent chip kit Uno 32. It's a kind of a Arduino work-alike board, but instead of just having the I think it's like 12 or 13 I/O ports that the Arduino has, this one has close to 30 something I/O ports on it. It's also a 32-bit processor. Its entire function in life is to take the commands that we send over this serial cable and convert those into actual step and direction signals that go to these drivers. These drivers here are what take the motor voltage, which is the 12 volt battery. Looks a bit like this. It's a lithium ion battery, or sorry, lithium polymer actually. 2.2 amp hour, so it's a fairly hefty little battery. It takes 12 volts from that and converts those to the coil voltages that go to the two different coils in the stepper motors. And then it steps those in just the proper sequence to get the motors to either move in forward or reverse, and at whatever speed you want them to move. So that's kind of the overview. That's all it is right now. It has no input, no sensing ability. It just does what it's told and moves where it's told to move. So here early on I want to go ahead and get the metal deck built for it, which is going to be made out of aluminum over here. And then I have some other deck material here that's going to be for some of the upper decks, but this is a little bit thicker and will be used for the bottom deck. And so we want to get that metal deck built so that it's got a little bit something more sturdy than this fiberboard. So anyway, I will go ahead and shut up now, and we'll demonstrate a few of the movements that it can do as of now. Alright, try to get some video of it actually doing something here. So we'll start out with something fairly simple. We're going to tell it to just move forward until we tell it to stop. So type in my command here, the serial prompt. And we're going to tell it to move fairly slowly. We'll say 75 RPM here. And you'll see it's got a fairly strong curve. There's a couple of reasons for that, one of which is that caster wheel in the back. I hate that thing already, and my final design is not going to have a caster. Part of the problem I'll explain a little bit later here. So now we'll tell it to come back in reverse. 25 RPM. Okay, tell it to stop. Okay, so that's forward and reverse. Now we'll go ahead and set it to move at the kind of the cruising speed that I've set for it, so about 1 foot per second. Okay, so let's bring it back at the same speed. Okay, so that's the cruising speed. It can actually its maximum speed is about double that. The downside to moving much more quickly than this is that the motors actually start to lose power. The faster they're spinning, the less power they have, and by the time you get up to 2 feet per second, they're really fairly weak. And so I'll show a couple of the other more interesting moves here. It can spin in place. So if we run one motor forward and one motor backward, and it does a nice neat little 360. And wraps itself up in the cord very nicely. Now you can also do a different kind of turn. It's basically very similar to a tank drive. So to make it turn, you move one wheel faster than the other, or in opposite directions. So if we want to make a little bit less drastic of a spin or a turn, we can go and tell one motor to sit still. So we'll tell the A side to sit still, and one motor to move forward. And the result is it turns around on that one wheel. Backward. So if you want to make a much more gradual turn, we can tell one motor to go ahead and move forward. So we'll tell it to move at, say, 50 RPM. And the other motor we will move at 75. And the result is a much more gradual curve. And so that's the basics of it. Nothing really super exciting right now. Like I said, it has no sensors, so if it bangs into something, it just bangs into it, and just keeps trying to bang into it. So it only does what I tell it to right now. A couple of issues that have cropped up that I ran into. One of them that contributes to that it tending to move towards one side more than the other is when I made the pulleys. I made these pulleys. These were the first ones that I made, and I did them mostly by eye. So I just watched for when it looked like the groove was opened to the proper amount, and then I quit. On this side, I actually did the math and moved my tool just exactly the amount that it was supposed to be moved in order to open this the exact right amount to make this groove as deep to make this groove the right width. So the result is that over on this side, I came very, very close to my ratio that I was shooting for. I wanted 4 to 1. I came within, I think, 2% of hitting that. On this side, however, I did not. I think I'm closer to a little bit over 5% error on this side. So the result is that when the motors are turning at the same speed, these two stepper motors are actually turning at the same speed, the wheels aren't because of that difference in the pulley ratios. So what tends to happen is, since this one is turning a little slower, this one's turning a little faster, it tends to, over time, curve toward the side that's moving slower. I'm not going to remake those pulleys. In the long run, I'm going to change those to timing pulleys instead of V-belts like they are now. A timing belt has little teeth that are inside the belt, and then the pulley itself has teeth as well. Those mesh together. So you can run them with a whole lot less tension than what's required for a V-belt. These have to be pulled really, really tight in order for them to not slip. With a timing belt, they pretty much just don't slip unless you've got them set up really badly. So the bottom line is there that until I can get those timing pulleys made, I got to run with little V-belts, and all I'll end up doing is doing some calibration in here so that I turn this wheel a little bit faster than what it's told to go. I have a couple of other modes that I can actually run this thing in that I didn't show. One of them is I can tell it a distance that I want it to go in steps. So if I tell it that I want it to move 800 steps, it will actually turn this wheel one time. So I can figure out exactly how far I want it to go and tell it to go that far. Long run, I'm going to have some more advanced commands too, where I can tell it how many degrees I want it to turn, and have it do exactly that many degrees, or at least as close as it can get with real world. And some other things like having it turn various arcs, so I can have anything from turning right on this wheel to a very, very wide sweeping arc. So anyway, that's where it's at right now. I'll make some more videos as I get more done with it. I want to get this deck built, and I'm hoping to do that in the next few weeks. And then I'll start mounting up the sensors and mounting up the actual electronics a little bit more permanently. And I'll make some more videos as that time goes on, and hopefully I haven't bored you guys too much.